outside. Notice how different the shapes are. I think of this as a playground, and which shape would you prefer to have for your playground? One is real long and skinny, another one, the 2x4, is not quite as long and skinny, and then the 3x3 is a perfect square. And then the next question I want you to think about is, do they all have the same area? And if you look at the first one, 5 times 1 equals 5. So that area is 5. 2 times 4 equals 8. So the area is 8 for that one. 3 times 3 is 9. So the area is all different. So if you were playing maybe kickball, the 3x3 would be a good place to play kickball because you have all that space to kick the ball. Or maybe that'd be good for soccer. But if you were doing relay races, maybe the 5x1 would be the best place to have your relay races. On page 342, we're going to compare rectangles with the same area. Notice we're going to work a lot on area this time. So the area has to equal 12 square centimeters. So again, you can use your dot grid, or you can just use a regular sheet of paper to draw all the possible rectangles with an area of 12 square centimeters in sides, whose lengths are in whole centimeters. That just means no fractions. Label the lengths of the two adjacent sides of each rectangle. So if we were to draw just a really long rectangle, this could be a 1, and this side could be 12. So 1 times 12 will get us 12, and that can be the area. So it'd be 1 centimeter and 12 centimeters. And then they want to know what is the perimeter of that shape. So if this side is 12, and this side is 12, and this side is 1, 12 plus 12 is 24, plus 2 more, 26 centimeters would be the perimeter. So what would be another possible shape to equal an area of 12 square centimeters? Well, I know that 3 times 4 will give me 12. So we could have 3 centimeters and 4 centimeters. And if we added up all the sides, 4 plus 4 is 8. 3 plus 3 is 6. 8 plus 6 is 14 centimeters. I want you to figure out what the third rectangle could be, and if you would please answer that right here. Figure out what that third rectangle would be, where the area is 12, and then you have to figure out the perimeter from there. Next one we're going to look at is rectangles with an area of 18 square centimeters. So I know that 3 times 6 is 18, so I could make a rectangle that is 3 by 6. So I could have 3 centimeters and 6 centimeters. And then I'd have to figure out what the other sides are to figure out the perimeter. So this side is also 6 because these sides are equal to each other. If this side is 3, then this side is 3. 6 plus 6 is 12. 3 plus 3 is 6. 12 plus 6 is 18 centimeters. There are 2 more rectangles that I want you to discover on your own. So what else would equal 18 if you did something times something and then figure out the perimeter? And then there's one more rectangle that I want you to figure out and figure out the perimeter. When you're finished, please look in your math book to see how you did. The last piece on this page I want you to do is number 11. You don't have to do check for understanding. It says compare the shapes of the rectangles with the least and the greatest perimeter. So on this line, just explain what those rectangles look like and how they look the same or different. When you're finished with this page, go to the Schoology course and check your answers under math.